In this next section, we're going to be solving systems of linear inequalities. So unlike an equation where we will have two lines that cross on exactly one point, inequalities overlap in an entire region, so not a single point. And we do this in a similar way to what we did the last part, which is that we do each of these things separately. So we have this equation, y is greater than negative x plus 3. A few things I want to do that right away. I want to put a negative 1 in front of the x instead of just a negative sign. Helps me remember what the slope really is. And second, I want to treat it like it's an equal there. So I'm going to do what I normally do, which is plot my y-intercept at 3. And a slope of negative 1 is also a slope of negative 1 over 1, which means I go down 1, right 1, and so forth. Then I have to decide if I do a solid or dashed line, and that comes from the symbols here. The symbols that are greater than or just less than are going to be dashed lines. The ones that are greater than equal, less than equal, those are going to be solid lines. So in this case, this first one, y is greater than, is going to be a dashed line. Since it's y is bigger than, y is greater than, we shade above for that particular line, for that region. Then we go to the bottom and repeat the process. So treat it like it's a line, which means I have a y-intercept of the negative 1 right there. I have a slope of 3, so the 3x means a slope of 3. So I go up 3 over 1, up 3 over 1, and so forth. And I see that that one's going to be, based on this symbol here, is going to be a solid line. So I have that one as a solid line, and it says y is smaller than, y is less than. So I'm going to color in this region right here. Now to solve the linear inequality graphically, I want to trace out and make clear my overlapping region. So the overlapping region is right here. And this goes outwards forever and ever and ever these directions. But for the purpose of our graph, all you need to do is shade the visible part. So that overall region is the entire solution. The point 1, 2, this point right there, is actually not a solution to this problem. So you have to be careful. It's not where the lines intersect, it's where the regions overlap in this particular case. This next one, we have to start by getting y alone before we can do anything. This one's going to throw a little curveball at us. On the top equation here, we have a positive 3x that we want to get rid of because we're adding a negative y, let's remember. So if I have a negative 3x that I add over on the left, and then I add a negative 3x over on the right, those reduce down to just negative y. It is less than 2 plus a negative 3x. Now remember, negative y is the same as negative 1y. So I'm going to rewrite this problem as I have it. Negative 1y is less than or equal to 2 plus negative 3x. When I want to get y alone, I need to either multiply or divide everything by negative 1. So I'm going to, multiplying is a little easier for me, so I'm going to multiply everything by negative 1. And as I go through each term, I have negative 1 times negative 1 is just 1, so 1y. On the other side of the inequality, we have 2 times negative 1 is negative 2. And then we have a negative 3x, which becomes a positive 3x. The tricky part is whenever you multiply by or divide by a negative number, such as -1 like that, that symbol gets flipped around. It will end up becoming that. So if we had to graph that, I would go to our y-intercept of -2, where we start, and we have a slope of 3. So 1, 2, 3 up over 1. And graph that real quick. The other problem here just has x plus y, which means that we just need to add a -x to both sides. And now we have y is greater than or equal to 2 plus a -1x. So instead of 2 minus x plus a -1x is a little bit easier to work with. Now a y-intercept of 2 is going to be right here. A slope of -1 is going to be this way, so it should not be an issue. Now we're going to look at the symbol. The symbol says that it is a solid line because it's greater than or equal to, just like the other one was a moment ago. The other thing it says is that we are shading above because y is greater than that number. So we're going to shade above that. Going back, realize that we forgot to shade on this first one. This first one also says y is above that or greater than, so it's going to be up in here. Meaning that our region, our solution region, is going to be this area right here. And again, that extends forever, but for the purposes of our graph, it is that shaded region that is bound by our inequalities. And that is all.